Okay, to start off question number 12, because it's the area between a curve and the x-axis, all we do is we just determine the antiderivative there because we'd be subtracting 0 from it. Now, I'm going to go ahead and set this up, and when I do u substitution, I will get 1/2 the integral of u to the 1/2 du. Okay, next thing we need to know here is where exactly this graph will cross the x-axis. That would be our upper and lower limits. So we set x equal to 0. So 0 would be the lower limit of integration. And we set 4 minus x squared equal to 1/2. Now, there we would get 2 plus x, 2 minus x. So we get x equal to -2 and x equals to +2. X equal +2 is the only one we're concerned about because we're just talking about the first quadrant. So I'll be going from 0 to 2 here. Also, this derivative should have been negative and negative, so I'll get a -1/2 out here. Okay, now we go about substituting in so that we don't have to substitute back in the end. If I plug in 0 in my u equation, I get 4 minus 0, which is 4. And if I plug in 2, I get 4 minus 2 squared, which is 0. So I'm going from 4 to 0. Now the problem with that, of course, is that I've got this should be my upper limit, this should be my lower limit, so I can switch them by changing the sign, which is good because I don't want a negative out here. So it will be the +1/2 of the integral from 0 to 4 of u to the 1/2 du. Now, from here, we just go ahead and I differentiate. It will be u to the 3/2 times 2/3 with the 1/2 out here. So that cancels out. We got our Kipchumba here. So the square root of 4 is 2, and then 2 cubed is 8. So it's 1/3 times 8, which is 8/3.